Welcome everybody to our live demonstration for the pharmaceutical industry here at VEGA in Schiltach in the Black Forest in the headquarters of VEGA. My name is Natalie Waldecker. I'm product manager here responsible at VEGA for the pharmaceutical and food and beverage industry. Yes, in the next half an hour we will give you an overview about the different applications for the level and pressure solutions what VEGA can provide specific to the pharma industry. And we have also prepared some live demonstration models here to show you a few examples. So therefore, if you hear some sound in the background, this is just because our working models here.
Hello, also from my side. My name is Florian Burgert and I'm also in the product management responsible for the food and beverage industry as well as for pharma industry. We now will start with our live demonstration.
So first of all, we will have a look into different applications in the pharma industry and where level and pressure solutions are needed. So therefore, we will start with the beginning, where the raw materials are stored. Here we have to make sure that always enough raw material is available to maintain a continuous production later on, and therefore the level is monitored as well as point level sensors are included. But now let's have a look in the upstream process where the actual active ingredient is produced. So here we have the bioreactor. Also here we have a very hygienic environment, and therefore even there level has to be monitored. Also some kind of overpressure here what we see. But then let's go further in the downstream area. Every time after several production process steps, also the components have to be separated, for example, via a filter system. Also here the filter has to be monitored, in that case with an electronic differential pressure. But also as soon as the the product is finalized, it also has to be filled up into small bottles, for example, and therefore also the storage has to be monitored before it goes into the filling of the bottles. And not to forget, also the cleaning plays an important role. So the zip and zip cleaning, meaning over temperature, and also adding some additional sterilization process. And here also, even during that cleaning process, for example, if there's a spray ball included and starting the cleaning, also the level has to be monitored. So, but what are exactly the challenges in that industry, and what do our sensors have to withstand during that process? We will have a look on as well.
Yeah, as you see in this selection of applications, there are a lot of challenges for our sensors. We have some foam, we have steam, we have high temperature and also low temperature, it depends on the cleaning, and we have some high pressure and low pressure as well. So the sensor has to be really robust. Robust from the mechanical standpoint because of the temperature jumps, and also very reliable for measurement over all these conditions. The second thing is that the sensors not has to be 100% reliable in measurement. It's also that in that branch that you have to have different certificates. For example, we are only use FDA-approved devices when we send it to the pharmaceutical plant. We have a third-party verification for all our materials. Additionally, mainly driven by the food industry, we have 3A and EHEDG for the hygienic design of our sensors. This is also a help for you in the pharmaceutical industry because all our hygienic process connections are designed regarding 3A and EHEDG. So the cleaning of our sensors is all the time the same because the construction is done by EHEDG and 3A regularities. The second thing is that also the traceability of our sensors is maintained during the complete line from the raw material till the sensor is in your plant. And this traceability takes place with a GMP regularity, and we check all the parts from the very beginning till the device is in your plant.
So to produce the actual medicine, always cells and microorganisms have to be cultivated, and this takes place in a bioreactor, what you can see here also in the animation. Important is that here always is a sterile and hygienic environment, so any kind of contamination have to be excluded, because this can affect the quality of the end product, because, for example, a false reaction can take place. In that case, even still, the level has to be measured, and here we have a very nice solution with our VEGA Pulse 64, as you can see here. But now we also have a look in our demonstration unit, because also here we have a VEGA Pulse 64 installed. This is a free space radar, 80 gigahertz technology used. And also what you can see here on the hand model, there's only a small portion which is inside of the vessel. So there's not a lot of parts which have to be cleaned. The antenna is completely encapsulated with a PTFE coating, which makes it very easy to clean. But not only that is an advantage, also the 80 gigahertz technology, what we're having here, because here we have a perfect focusing, especially on bioreactors, where we have agitators or any other installations inside, doesn't affect the measurement signal, even if there's a fluctuated surface. But here we saw even small vessels, but sometimes in the industry we have much more or much smaller vessels also, where the level has to be monitored, and sometimes not even process connections are available to install a sensor. So Florian, how does our solutions look like in such cases?
Yeah, here we have an example with a 2-liter glass column, where we have a demonstration for small vessels. And here we have a special version. We have the version with a glass column, and we installed VEGA Pulse 64 above with a thread connection. Normally a thread connection isn't the right thing for pharmaceutical industry, but while we measurement from the outside, it's independent of the material and it's independent from the hygienic design. So that's really easy and a good solution with the radar technology, free space radar, to measure the water column through the glass without any demand to the sensor, and has a high cleanability and high aseptic solution for this media. So nothing will come into this media because the glass column is closed. For this demonstration, we have the VEGA Pulse 64 connected with Bluetooth to this iPad. And on the iPad, we have here 29% of the volume filled into this vessel. When we now fill in some water more, you will see that you have an increase of this percentage, which gives you the information, okay, while filling water in, water level increase, and then the sensor will measure this with the glass. So I filled water in, and you see the percentage, it grows, so we have filled in more. The linearization is done, so we have a good step, and we come on with a higher level measured from the outside. When we now have a look on a real application from a VEGA Pulse 64 with a reactor made out of glass, because internally we have a high demand on aseptic, and we have a really high chemical aggressive media inside. This is very easy measured with a VEGA Pulse 64 and with plastic horn antenna, so it's a standard easy sensor. We measure it through the glass of the water column, and we have an easy measurement from a standard device with a high demand application. The second application I want to show to you, it's in a laboratory. We have a very small vessel, only 24 centimeter measuring range. Because of there's no blocking distance with the 80 gigahertz antenna, we can measure the full measuring range. This example shows you that you can use the VEGA Pulse 64 in the laboratory with the very beginning of your development of a pharmaceutical device, pharmaceutical ingredient, And when you scale it up in your process, you can use still the same sensor. You have still the same evaluation for the sensor from the laboratory up to your upscaled production.
This sounds really like an interesting solution. I want to add here one additional example which goes in a similar direction, because more and more often personalized medicines or even smaller batches of product is required. And in that cases, such types of single-use bags are used. The big advantage is here that they can be used very flexible. So this means it can be reacted very fastly on changing market demands. And on the other side, the effort to clean the vessel or the bag in that case is reduced dramatically, because for each batch a new bag is used and always there's a sterile environment. But nevertheless, also here the level has to be monitored. How does this work at the moment? Very often contacting probes are used, so they are inside, and the difficulty is there because of the very small level which has to be measured, so it's inaccurate. And always also sometimes used are weighting cells, so the level is determined via the weight. Also this can be false, because during the filling of the bag it expands unevenly, and therefore the weight is not exact. So in that case, what can we do? Also here we use the VEGA Pulse 64. We also measure through the bag, similar what Florian just showed us in the glass bowl. It's not glass, but in that case it's polymer bag. But it works in the same way, even if there are wrinkles inside during the expansion of the bag, and even if there's condensate. So really clever solution, not only with glass, but also on the polymer bag.
Yeah, all these applications we've shown till now was the upstream process. So the process where the bacteria, where something is growing in your process. Now we want to have a look at the downstream process. One of these downstream process is the vacuum evaporator. Here you have the media with all the neutral solution internally, and you have the ingredients. While putting, for example, alcohol, you can separate the nutrient from the active ingredients. You separate them there, and after the process was run, you want to get the alcohol out. Therefore, you need high temperature on a low pressure. You need that low pressure to go down with the boiling point to get the alcohol easy out with the steaming. So in that application, we use the VEGA Pulse 64. It's independent from the steam of the alcohol, of the vibrations from the mechanical construction, and you also have the fluctuation in the level. And everything is, under all these conditions, the VEGA Pulse 64 is working. Same application, but different measurement. We have the electronic differential pressure. In that solution, we measure the pressure and we measure out the level of that. Typically, we use classic differential pressure with a capillary line, an oil-filled system. Oil filling with high temperature and low pressure gives often the problem of a drift. You have to recalibrate the sensor often, and on a specific time, you have to rechange it. When you use a ceramic sensor on that case, and VEGA bar 82 with a ceramic cell, then you can go with the ceramic cell as a dry measuring cell. You can combine two sensors to an electronic differential pressure, and the dry measuring cell has no oil filling. So there is no liquid intern that can boil. So with that measurement, you have a high reliability under high temperature and low pressure. So it's a really clever solution.
Another method to separate the different cells and microorganisms is it via a filter system, as you can see here in the back. Here we also have to monitor the filter if there's any kind of buildup, for example, to make sure or to plan any cleaning process of the filter. So the monitoring of the filter is also done in that case via an electronic differential pressure. So we have a sensor installed before the filter and one sensor installed behind the filter. Together they are combined with a cable, and they are then an electronic differential pressure system. This means as soon as the pressure rises, you know as an operator that the filter is blocked, that there's buildup, and it has to be cleaned. Let's have a look on our demonstration unit again. Also here we have an electronic differential pressure system installed. Here above we have a pressure devices which measures the overall pressure. And also on the back side there's another sensor installed at the bottom to measure the hydrostatic pressure. In that case they are just simply mounted and then connected via a normal standard cable. So here the big advantage is the easy mounting via the cable, no oil filling inside, no capillary systems, and therefore also no influence when there's temperature changes included. Another big advantage is that you are very flexible in the selection of different versions, because it can be used on the one side, a sensor with a ceramic cell, so we have the ceramic included, with an O-ring inside of the process connection, especially when we have very abrasive media. Or on the other side, if it should be a very hygienic, completely stainless steel, we have the metallic cell on the pressure devices where there's no O-ring included, so this means also no O-ring have to be exchanged. And even they can be combined together in the electronic differential pressure system, and a ceramic or a metallic version also in the combination. So now we have seen a few applications, especially on the liquids, but of course also in the pharma production there are also solids available. Florian, what types of solution do we have for solid applications?
Yeah, Natalie, for solid application we have also a solution with our VEGA Pulse family. For example, we have for granulated goods, for example for salt in the production of the pharmaceutical goods, we have the storage of in the big packs. The big packs can also measure with the VEGA Pulse 69, and the good thing is the VEGA Pulse 69 can measure through the closed big pack, so you don't have to open it. It's similar situation like the Pulse 64 with the glass tank. So the VEGA Pulse 69 has also good focusing at 80 GHz, so even the metal construction where the big pack is hanging in, it has no influence. You just measure the level internally, and it's very easy to follow the measurement. There's also a good solution, the VEGA Pulse 69 with a contactless radar measurement. When the big pack is empty and you come there with a device to dismount the big pack, then you can fill the new big pack in and you have no contact to the VEGA Pulse 69. So it's quite easy without any mechanical influence on the VEGA Pulse 69, and you have a very, very reliable measurement even when it comes to solid measurement. So we have now shown you the upstream process, the downstream process. We have also shown you a small application for solid handling. When you are finished with the production, you have to clean your environment. And that's the next application where we talk about cleaning.
Yes, the cleaning plays a very important role in this hygienic industry. So this means sometimes even complete skids have to be cleaned, sterilized, typically in the autoclave. So where a lot of temperature, high temperature, and also pressure is added. But of course, what you do not want to do as an operator, you do not want to dismount all the sensors and then go into the sterilization process. In that case, we have a special version. It's the VEGA Flex 83 as an autoclavable version. So we have here the probe, it's the guided wave radar. Here we have the media which is in contact with the probe, and then we have the electronics. And for the autoclaving process, you can disassemble the electronics because the electronics cannot withstand such high temperature and also the pressure. Here we have a blind plug which protects the electrical connection, and like this you can have it the complete skid including the probe mounted, and then put it into the autoclaving system, autoclaving process for the actual cleaning. And later on, afterwards, of course, the electronic is installed again, and it starts all over again.
Yeah, when we talk about the autoclave has to be fed via the steam. The steam has to be produced out of water for injection, and how to produce the water for injection will be shown in this distillation, in this condensator. The condensator works like that. From the left side, the steam is coming in, and then you have the condensator with the cooling line, and the water for injection goes out. When you have a look there, you have two types of sensors here. In the cooling line, we have the VEGA bar 28 with a low demand at the hygienic design, because it's only the liquid inside, the cooling liquid, which cools it down very easily, and you have no direct contact to the media. The media here is water for injection, and the VEGA bar 82 is directly in contact with the water for injection. So this sensor has a high need to be robust and to be inert against the media. Therefore, we use the VEGA bar 82 with all the FDA approvals to make sure that nothing from the sensor goes into the water for injection, to keep the water for injection really, really clean.
So we have seen now that a lot of, or all of our sensors meet the hygienic requirements regarding the cleanability, also regarding the regulations. But in the end, what can our sensors add to make the life for you as an operator easier, which in terms of the operation and diagnostic reasons, and also to maintain the hygienic regulations? And therefore, we will watch a short video. So we have seen in the video that the operation and also the diagnostics via the Bluetooth functionality with our VEGA Tools app is a great opportunity to comply with the hygienic regulations on the one side, but still have access to the sensors for the diagnostic.
Natalie, can we have a look live on that with Bluetooth?
Yes, we can do that. We have prepared here a set with the tablet and the VEGA Tools app here installed. We have here a VEGA point, which is connected via an M12 cable to an IO-Link master. And now I will start the connection. So let's have a look where it is. Here we have it. So I see it here because of the serial number. And now it's starting the connection. You see it blinks blue. This means the connection is established to make sure that also the correct sensor is chosen. And in that case, now I have the connection established. I can do a lot of different adjustments now. In that case, I want to change the light ring, what you see here. because at the moment it's just the default setting as it comes from the production here from Schiltach. So this means the switching status is yellow, and as soon as the sensor is covered, it's green. So I do not want to have that in that case. I want to have another adjustment. So I go into the setup, and then I use the 360-degree status indication. I don't want to have it like that. I want to have it individual signaling. I don't want to have the yellow. I want to select another color. Or individual I want to have. And now I can select starts. So it needs a little bit of time. So now I change it to the color I want. In that case, I just selected a purple color. So now, of course, the sensor is in operation, but maybe it has to be exchanged at one point. So I have a new sensor here, prepared directly from the production. It's also a VEGA point. I connect it again. So you see, it's also the default setting, and the covered status is also green. So this is my new sensor here. I keep that, and I don't want to have that sensor, which has to be exchanged. So this one goes away. And now I start the connection again. And you have seen it directly. Also, the setting of the light ring was used or transferred again automatically because of the backup and restore functionality what we have included. So all the setup is stored in the I/O link port and then transferred automatically. Also, all the adjustments I have done via Bluetooth. So this is a very easy way to save time and make your life as an operator easier.
As we said at the beginning, we do not deliver only the devices for you. With the device in your branch, we deliver the paperwork. With your device, you will get, for example, the declaration of conformity regarding the FDA with all the information internally. You will get the instruction to make the assembly and the cleaning of the sensors in hygienic environments. In case you are in an explosion-proofed area, you will get the safety instructions. And for sure, for the traceability, when you order the cleaning from us, you will get a certificate of the cleaning in a printed version, as well as a material certificate for the metal parts, where you have the complete traceability from the very beginning of the metal till you have it in your plant as a metal process connection.
Okay, so this means a lot of documentation comes with the actual shipment, but how about an earlier stage? Because when a skid or a plant is built, also the documentation and the relevant information has to be available at an earlier stage. Because in the end, you as a plant builder have to know the effects which come from the sensor. For example, what kind of materials do we use? How does it affect the product which you want to measure? And all these test results we have available on our website at any time. So therefore, I have prepared here also on our tablet the VEGA Bar 83, which is our pressure transmitter with the metallic cell. And here you get all relevant information directly available. So this means, for example, you can configure your product with the, for example, approvals you want to have, and also the process connections you need, including the material which is in contact with the media. But that's not all. This is by the way, always available. You can also go into the download area where even more documents and certificates are directly published, like the FDE and EG 1935-2004 declaration, which means all the test results regarding the material. But of course, not only the material, it has to be considered, also the mounting orientation, which has to be planned in the production. For example, here we have the 3A declaration and certificate and the recommended mounting orientation in case there's a leakage inside, and the leakage bore has to be in the correct position to make sure that the liquid drains out and has the possibility here. So this means also during the project planning, the information is available very easy.
The next question we want to answer is, how can you get the access to the information when the sensor is installed, like this VEGA Pulse 64? On the type label of the VEGA Pulse 64, we have included a QR code. Inside of this QR code, we have a unique identifier of that device. And the good thing is, you can use your smartphone, open the camera, and scan this QR code. Then you can click the link, and you will go immediately to the VEGA homepage. And on the VEGA homepage, you get all the information to the sensor. You have here the complete sensor, which is the order number, the serial number of this sensor. When you go down, you will find the device information of all the configuration of this particular device. And you're going to go further. You will find also operation instructions, safety manuals, and all the documentation you need to maintain the sensor. When you go into the MyVEGA and log in, and you are the owner of this sensor, then you get even more information. For example, the 3.1 certificate includes your customer information. So we can't put it into the standard device search. So when you are logged in and the sensor is yours, then you will find there all the related documentation from the 3.1 certificate, the Bluetooth codes, everything is stored there to give you the access and the information to the device.
Yeah, so this means the information is available throughout the entire process, from the planning of a new project until the shipment, and even if a sensor is already installed, the link to the correct certification and documentation is always there. Yeah, now we are at the end, I think, of our live demonstration. So we hope we could show you a lot of different applications for the pharmaceutical industry.
Then we have to say thank you. Thank you for having us, for joining our live demonstration. Thank you, and if you have more questions, please feel free to contact our salespeople worldwide, and we are happy to see you in the future. Thank you.
Thank you very much, everyone. Have a good day. Bye-bye.